Hey folks, how's it going? This is Mr. Murray coming to you with a do now for course 1 CP for our 319-2020 lesson. So in this do now, what I want you to do is I want you to graph the function on the coordinate plane. Sorry, I shouldn't say same, it should just say graph on the coordinate plane. Do not forget a table. Okay, so what I want you to do is I want you to try using what we know about vertex form so far. And if you need to, this is an okay time to stop and maybe go back to a previous lesson. I want you to make a table, x, f of x, or x and y. Make a table. Use that table to make a graph containing at least the vertex plus 4 points. Okay? And you should have 2 per side of the vertex. So please pause the video, try to make the graph, including the table, and then when you're ready, unpause, and I'll show you how to do it. Alright, so keep in mind, you're going to see some stuff like domain, range, and stuff. Don't worry about this. I know I did not ask it in the question. I'm going to do it for you for this problem, because today I'm going to ask you to fill in the analysis for the surprise vertex form. Again, if you haven't done that, please go back to the lesson for the previous day, 318, and make sure that you did that activity so that it will be meaningful for you. All right, so I'm going to make a table here. All right, and what we know about vertex form by this point is what am I going to start by plugging in for x? I'll start by making x equal to 6, which makes y equal to 4. So I have 6. Now if we look at this graph, do we expect this to be facing upward or downward? It should be facing downward because this leading number is a negative number. Okay, so what would I plug in? So now what I'm going to plug in is I'm going to plug in 5, and I'm going to plug in, or actually, let's play this one smart here. I'm going to plug in 4, I'm going to plug in 5, because I know that 6 is the vertex, and if 6 is the vertex, then since 4 and 5 are 1 away from 6, they will have the same y value. So I plug in 5, I'm getting myself, getting tired, wearing at me. 5, how about 5 and 7? Those are each 1 away from 6, and then 8 and 4 are also same distance, there, 2 away. So plug in 7, I get 1. 1 squared is 1. This makes it a negative 1. I add 4 and I get 3. And I copy that for both. 8, I subtract 6, I get 2. I square it, I get 4. This makes it a negative 4. I add and I get 0. So maybe that by this point you're starting to see that a lot of these graphs work out pretty similar. The idea of you're squaring 1 and then you're squaring 2. And hopefully if you can see these similarities, it's going to make graphing ones where you're really on your own a lot easier for you. Okay? So I'll go ahead and I'll add my points. I'm not the best artist, so I happen to know that I've got these points right here. So I connect. And voila, I have my graph. Let's talk about this graph. What do we know? Well, we know the domain. The domain is negative infinity to infinity, and that usually is going to be the case, right? And for this year, I said the domain's always going to be negative infinity to infinity. And that's usually true. You can usually plug in whatever you want for x. You might see in Course 2 Honors or Course 2 CP an example where that's not the case, and we cross that bridge, we'll get to it. But if you look at the function, there's no sign that there are any numbers that you cannot plug in for x. If there ever is, it will be pretty obvious, and when we cross that bridge, we'll see what we're working with. Range. So I know not all y values can come out. As you see, if I look along the y-axis, right, I start down here pointing down to negative infinity, but the y's never go higher than 4, right? This is the cutoff. The y's never go higher than this. So they can go as low as we want, but they never go higher than 4. And notice the 4 right out of the vertex. Where is it increasing? So remember, we always go from left to right. So as I go from left to right, I'm increasing from negative infinity to 6. Remember, we're always using x values. And for increasing, we're using parentheses because at 6, we've leveled off. And we're neither increasing nor decreasing. And we're decreasing from 6 to infinity. Okay? Notice again, the 6 from the x of the vertex shows up in the increasing and decreasing. So that's another way to see whether your answers make sense. This is saying, where are the f of x values more than 0? So if we look, where is y greater than 0? I'll do it in green. It happens from when x is equal to 4 to when x is equal to 8. And it's negative at all other times. So when from x equals negative infinity all the way up to 4, and from when x equals 6 all the way to infinity. Remember, you don't use negative infinity because I'm talking about x values. So we're going this way. We're continuing on to negative infinity. So this would be 8. And observe here how the x-intercepts show up in the positive and negative. So these are ways to check to make sure whether your answers make sense. Okay. Finally, I get 4, 0, and 8, 0 for my x-ins. And to get the y-intercept, even though we can't see it, what would I plug in for x? It'd have to be 0. So I would do 0 minus 6, which is negative 6. Negative 6 squared is 36. The negative makes it a negative 36. I add 4. I end up with 0, negative 32. And quadratics are just kind of funky like that. All right, so I hope you found this to be informational. If you were able to get the exact same graph as me, great. If not, please think about, did you make a table or not? And if you did, which I hope you did, please check your table against my table to see if there's any possible errors you might have made. All right, so I really appreciate your hard work and your devotion. Keep the questions coming. Don't get down about this. It's not easy stuff, but remember, you can do it. Okay, thanks for tuning in. Feel free to like or subscribe, and so you get the latest updates to my videos. Don't forget to love math, and have a wonderful day.